Good morning, everyone. Dr. Christopher Tassone here from Sama Learning. Today I want to tell you guys a little bit about quantum mechanics and chemistry, and what it's used for is to develop atomic orbital theory. What atomic orbital theory does is try to explain where electrons are spending the majority of their time in atoms. And what we can see here is actually an illustration of the first reason why atomic orbital theory is so different than other types of theories we've learned about in the past, is that it doesn't obey classical mechanics. In other words, there isn't a continuous function which describes exactly where an electron is at a given time. In a quantum mechanical system, the best we can do is pick some volume and calculate the probability that we'll find an atom there, or an electron there, excuse me. And so what we see here is a map where the brightness and the size of these dots in each volume element tells us about the brighter it is, the higher the probability, and the darker it is, the lower the probability of finding an electron there. Quantum mechanical systems are quantized. That's where the name comes from. And so what that means in practice is as we change one of the principal quantum numbers, in this case n, from 1 to 2, we see a step change in how large the electron cloud is. And as we go to 3, we see an increase again. Now this is as true for the size as it is for the shape. So the angular momentum is quantized in a quantum mechanical system, and that leads, when you have an angular momentum of 0, you get a sphere, or an angular momentum of 1, we get an entirely different shape. Let's look at the surface instead of the probability cloud here. You can see that we get this dumbbell-like shape, and as we increase the angular momentum still, the shapes increase in complexity. So the first thing that we have to understand in quantum mechanics is that things are behaving really differently than anything we've experienced in our life. And when we talk about quantized systems, we really just mean that there are discrete shapes, sizes, and energies associated with the system, and not a continuous trajectory between them. Thank you so much for listening, and I look forward to seeing you in future videos.